Good morning. Welcome to day 2. Everybody having a good time so far?
Yes.
Great. All right, well, my name's Matt Usher. I'm a senior program manager in the Analytics Platform System and SQL Data Warehouse service team. And we're going to talk about an Azure SQL Data Warehouse. So how many of you are actively implementing a data warehouse or have an active data warehouse in your system? Terrific. How many of you have that based on SQL Server? Wow, that's pretty good. How many of you have it on something else? Okay, holler at me what those systems are outside of SQL Server.
Oracle.
What is it?
Oracle.
Oracle. Anything else other than Oracle? Any SAP folks? Netezza, Greenplum? Greenplum, kind of a mix. Whenever I give talks about kind of data warehousing, everybody always tells me, "Oh, I have a big data problem. How do I solve this big data problem?" So, by show of hands, how many of you have a data warehouse over 1 terabyte? Should see quite a few hands. That's pretty good. How about over 10 terabytes? A few. Anybody over 100 terabytes in the room? No? Okay. So that's pretty typical. It's actually pretty common. Most people don't really talk about big data and they say, "Oh, I've got a petabyte of data." That's actually pretty hard to produce that much data. There's very few companies in the world who actually produce that kind of data. But those 1, 5, 10 terabyte kind of systems are pretty common in data warehousing. So SQL Data Warehouse was built directly to address kind of the audience that we're here kind of sitting with, talking about kind of the size of data, the amount of data, the tools, the integrations that you have today. So I'm going to start this with kind of talking about how this product was built. And really this is going to be kind of a journey on how Microsoft came to build Azure SQL Data Warehouse. And when we thought about how we were going to build this product, this is one of my favorite quotes of all time. My mom used to have me read Emerson as a child, and so this is actually one of the things. It's a famous Emerson quote. And it really talks about kind of approaching a problem. And people use this quote quite often. And it really talks about how do you look at a problem and think, I could follow what other people have done, I can use the technologies we have in place, we could think about the way that things have done, or we could think about the problem in a new way. And Azure SQL Data Warehouse thinks about the problem in a new way. It presents some new and interesting ideas on how you approach the data warehousing problem to address some of the things that have always been a critical kind of falling down of building a data warehouse at scale for most companies. And so really when we think about how the product team went to architect the system, how we brought it with integration with other products, both Microsoft first-party and third-party products, we really try to take an approach that listened to our customers. And that approach was based on kind of 3 basic things. So when we introduced the SQL Data Warehouse, we talk about it on 3 kind of core premises. It's really based on these kind of 3 principles, and you'll hear me talk about those 3 kind of principles throughout this. The data warehouse itself is truly a fully managed, enterprise class SQL data warehouse running at scale in the Azure cloud. It gives you the capabilities of all of the things that you would expect from a cloud-based service, so burstable compute, burstable storage, with all of the first-party and third-party integrations that you would expect from a product that runs at this kind of scale. If we're really talking about true enterprise-grade products, it's really something that you would expect from Microsoft to offer. And it's based on these kind of 3 principles, like I was saying. The first is this concept of elastic scale and performance. And we'll talk about this quite a bit. But the core concept here is this disaggregation of compute and storage. So how many of you saw the build announcement by Scott Guthrie last week announcing this service? Many of you see the video? Okay, quite a few folks. How many of you saw the SQL Server Foundation session yesterday with Sean and Rohan? Probably about the same number of hands. So really the concept here that's been spoken about is really the separation of 2. When we go out and we talk to customers, myself, my team, my peers, my bosses, we really hear the same kind of theme. When we build traditional data warehouses on premise, it's really focused on the problems that we've always tried to solve. Hey, how many cores do I need? How many spindles do I need? What network throughput do I need? All of these kind of core computing problems. But it's really missing the point of the question. Nobody builds a data warehouse because they want to have 32 cores, or 64 cores, or 12 terabytes of RAM. They really don't build a data warehouse for that. They're actually trying to answer a business question. I have a set of customers who are looking at this kind of data, whether it's a website, whether it's shopping through a store. And we want to find out what other things can we do as a business to make that store experience more efficient for the customer. So shopping cart recommendations or fraud detection or all those kinds of things that a business is really, truly trying to get after. in the history of data warehousing, that's always been solved by a bunch of folks then saying, well, I've got to install software, and I got to go configure hardware, and I got to figure out how fast I need to be able to get all my data loaded, and what SLAs I got to meet my data requirements, and all of these problems. But they've always been missing the point. That's not what a data warehouse is. And so really, as we started to build out this concept of SQL data warehouse, we thought the problem that people have is they spend a lot of time on infrastructure and not a lot of time on actually answering a question. So as a business, I'm not really getting as much value out of a data warehouse as I could. Kind of the second pillar of this is obviously it's powered by the cloud. So you get away from all of those infrastructure problems that you've had. You can easily provision the service. You can go online, provision a service very quickly, be up and running with the data warehouse that will scale from very small size to very large size, petabyte plus. And finally, the last pillar is really this kind of market-leading price performance. And so the SQL data warehouse is obviously in a competitive environment. I won't name the multiple customers and competitors that come to us and say, hey, we're implementing this on-premise, or we're implementing this in the cloud, or we're thinking about implementing this in the cloud. That includes some of our own services. You think about HD Insight, how do I leverage SQL data warehouse versus HD Insight, or when do I use Hadoop, and when do I not use Hadoop, and all of those kinds of things. From a price competitive perspective, SQL data warehouses is targeted at making this an efficient and cost-effective service for you. It's not intended to be some exorbitant system that's hard to get into and only available to the largest of customers in the world. It's truly intended to be able to be a system that can start very small with you and grow, and allow you to grow the system very quickly and still be a price competitive service so that you have all of the capabilities that you expect without having to spend an exorbitant amount of money. So let's talk about elastic scale a bit. So really the concept around elastic scale is this ability to separate what you do from a compute perspective and a storage perspective. When we think about data warehousing, there's all kinds of reasons that you would do this. You hear all the time from customers that say, hey, I've got a very hard, strict SLA of getting my data from all my source systems, running it through an ETL or ELT job, getting into my system and making sure that that data is available for the executives to come in at 8 o'clock in the morning and start to do reporting and analysis of what's actually going on. It's a fairly common scenario. Or I have a burst kind of compute mode where I'm going to have a bunch of people coming in, hitting the system very hard for, say, a couple days and then going away, whether they're doing deep kind of shopping cart analysis or they're doing predictive analytics around what a customer's going to do when they're driving a car, for example. That's kind of the canonical scenario that we've been using this week. How do I make sure that I understand this driver who's inserting a lot of IoT data coming from a device in their car that's saying, hey, I'm actually a pretty good driver. I follow the speed limit. I stop when I'm supposed to. And how do I feed that in the system and make sure that I can actually start to do real-time data analytics against that? And so this concept of really being able to take what you can do with a system and scale these independently gives you all kinds of opportunities that you don't have today. The first thing that you can do with a system like this is what we call the kind of the burst mode. So traditionally we think about things like a cloud ISV, for example. If you have a cloud ISV and you happen to be that kind of vendor, really what it means is that you can take this system and you can turn the system up and down at a moment's notice. You can literally scale the service in 60 seconds or less, and you can be able to serve your customers very quickly, so building on top of the Azure platform to offer your software as well. But there's also things like traditional enterprise data warehouses. So you have a balanced set of storage and compute, and as the amount of data increases over time, we're all adding tens of gigabytes, hundreds of gigabytes a week or a month or a day even into these systems. You want to be able to balance the amount of compute resources you have against that. And that gives you the same level of performance that you would see, even though your data set's expanding. So as that data expands, you can just add continued compute to that in order to see the query performance that you see today. So you start at 100 gigabytes and you see a performance level that is acceptable to your customers. And as that grows to a terabyte, 10 terabytes, 100 terabytes, you can continue to expand the compute to follow that. We call that kind of a balanced blended model. And finally, there's those traditional kind of archival scenarios. So how many of you have a large system that you take all of your data and you just shove it into because you have a compliance problem, or you just need to stick it somewhere that you're ever going to have to get to it? It's a file system, it's HD Insight, it's a data lake, right? It's pretty common. How many of you spend a lot of time, or never do, hey, I want to go get that data for some reason. I want to do advanced computation against it. I want to do year-over-year analysis, right? We all know what that problem looks like. It's very difficult, moving data in and out of the systems. So taking advantage of being able to scale compute and storage independently, you can leave all of that data in the system. You could look at your hot data using partitioning or other models that are common in data warehousing. You can have a very small amount of compute with a very large amount of storage. Literally, you could have petabytes of storage sitting there and a very small set of compute and still get the performance that you would expect over the kind of, say, hot or traditionally kind of warm data that you would see last 6 weeks, last 6 months of data. And it really gives you this opportunity to manage the system in the way that you need it, not something that some PM, somebody like me, sitting in a cube says, hey, I think most customers are going to want 32 cores, 256 gigs RAM, and 16 terabytes of storage. Because that's what I think, because I talked to one person. How many people would use that system exactly as I defined it? None. Nobody ever meets that. There's never an ideal situation that says, I'm going to match exactly what somebody specs. It's going to be dependent on your workload. You talk to a large retailer, and they'll say, this is how I use my system. You talk to another large retailer who does the exact same thing, they'll say, I use it completely different. And they have different needs and different requirements. So building a system that tunes to you, not something that Microsoft is saying, you're defining the system the way that it works for you. So whether that's large compute, whether that's large storage, or some blended model in between. The beauty of this system is that it does something that other systems don't do. It scales, and it scales immediately. If you saw the foundation session yesterday, that was a truly live scenario. That was a beta set of software. It was released actually yesterday morning, so about 4 hours before the session, and we demoed it to you live. So it did have some faults. You saw some of the UX experience in Azure is not complete. But what you saw is us resizing the system from one size to doubling the size of it, and we did that in 57 seconds on stage. That's a true scenario that's enabled for you. So you can go in and resize this on a moment's notice. So now all of a sudden you have these capabilities that you never had before. If we talk about ETLs, it's quite common that I have customers come to me and say, look, I have an ETL problem. I bought a system that's this big because I have to do this amount of data, get it pushed into the system, do my aggregations, and make it ready available to my customers in 3 hours every morning. And so I bought a system that makes that SLA possible. But the rest of the day, the thing just sits there. It's twiddling its thumbs. It's bored. And I'm spending a lot of money on that, whether that's in hardware, whether that's in storage, or cooling and power and all the things that come associated with this. The SQL Data Warehouse allows you to scale up and down immediately. So you can imagine that you run an ETL job. The first thing you do is you scale the service up. You run your data into it. You do your ETL or ELT into there. And then you scale it right back down. And so now you have a service that's burstable. And as your customers come in during the day, if you see that the system's under strain, you can just size the system right back up. And you have this capability to do it whenever you need it. Not when somebody says, oh, hey, we're doing an upgrade, or we're doing this or that. I mean, you can imagine what this looks like today with a traditional system. If I'm an IT executive and somebody comes to me and says, hey, I need more power. That means I'm going to call my vendor, I'm going to buy hardware, I'm going to get it shipped into my data center, I'm going to have to put it into the data center. Then I'm going to have to figure out how to expand the system, whether that's moving data across all of the system I have by buying bigger hardware, so moving from node to node, or moving from an entire cluster to a much bigger cluster, so kind of forklifting your data warehouse from small to big. Really, the SQL DW service gives this to you on demand. And so I figured I'd mix this talk with kind of a mix of how this is actually done. So this is a mock-up of the portal experience. This was shown live yesterday for the first time. And it's actually very simple. It's literally just a slider. You want to make it bigger? You make it bigger. You want to make it smaller? You make it smaller. And you can just slide this along. And I'll explain the concept of DW here in a bit. It's a measure of computational power. But really it gives you the ability to say, oh, I want to make it bigger. And I can do that on demand. I want to make it smaller. I just want to do that on demand. And you get complete control over the system. And it's really this simple. It's also enabled via PowerShell, as you'd expect. So it follows the same patterns that you see with Azure SQL Database. Now, one thing to note is actually Azure SQL Data Warehouse is just an addition of Azure SQL Database. And we'll talk about that quite a bit throughout this talk. But it follows the same patterns that you see. So a very simple PowerShell script. I've called out what my server is, what database I want to touch, and the service objective, or what performance level I'd like to set the system at. Yeah. Sure. Sorry, say your question again? Yeah, so that would be the hourly rate of compute. So currently Azure bills on an hourly rate, and so the system will follow that same model. And so you can expect things like pricing to come out in the next month or so as we get into public preview. So if we talk about PowerShell, it's really kind of the same PowerShell scripts you would do today to alter a Azure SQL database. There's no difference. It's the same patterns, it's the same principles that you've gotten familiar with running Azure SQL database. And so it's the same thing. We try to make this as easy and as simple for you as possible. And finally, you can also do this from T-SQL. So you have a variety of ways that you can interact with the system. You can think about REST API, so calling this from an SSIS job, for example, just using a simple REST API call. You could think about all the different ways that you can integrate with the system because we've made those available to you, kind of all the standard interfaces that you'd expect. One of the things that this kind of concept of disaggregated storage and compute really introduces is now the concept of essentially compute of zero. Imagine that you didn't have compute. What could you do with a system that didn't have compute? It really becomes an interesting concept. Maybe you can save, an hour or two of cost, right? Everybody knows that storage is a race to the bottom, as Microsoft and Amazon and Google kind of compete for essentially at some point what I'm assuming will be free storage, right? It seems that we seem to lose about a 5 to 10% cost every, couple months on the cost of storage, and it continues to decline. Some of these vendors will eventually, whether that's Microsoft or Amazon or Google or maybe a fourth player comes into play, that'll say, hey, you know what, storage is free. And really, storage is a commodity, right? It's cheap. I mean, you can store a terabyte in Azure Blob Store for, I can't remember what it is, $40 a month. I mean, it's ridiculously cheap. And it's geo-redundant, it's backed up all over the place. So really the play for data warehouses in the future, and this is kind of a future view of the world, is being able to just disaggregate that and say it's commodity storage. Everybody has it, it's cheap, just throw your data up in it. It's going to be cheaper than anything you can do on premise. And really, how do you get at that data and how do you process it as quickly as possible? And this concept of pause is really interesting. It gives you the idea that you could do something like, hey, I'm not using the system for the weekend, right? Many small businesses don't have, people that are working 24/7. They're not a worldwide business. So there's no need to be running the service the entire time. Just leave your data in place, sitting there in the same system that you would expect. You're just not paying the cost of compute. And again, we get down to that commodity storage rate. It really gives you the option of running your business in a way that's much more efficient, the way you would expect a cloud scale service to run. All of this is automatable. So initially, we'll have all of the expected, kind of automated paths that you would expect. So REST APIs and PowerShell and, portal UIs and those kinds of things. We're building out a scheduling system, so you can automatically schedule this. And it has the concept of being able to say, just schedule it for nights and weekends. I don't need the system to be on after 7 p.m. every night because pretty much everybody in my office goes home and it's not a worldwide business, so it's not follow the sun. So I don't need it to be on 24/7 where it's just eating dollars. I can literally just store the data at commodity rates. The ability to pause and the ability to restart, which is more important than anything, means that you don't have to back up your data, throw it into a blob container, tear down the system, and when you want to start the system again, bring up a new cluster and restore data over the top. Many of our competitors have that exact model, and it's painful. Doing that in our system would be painful, right? Backups are expensive. Restores are expensive. I mean, who's ever had a restore that took less than a second, right? Nobody. You start talking about hundreds of gigabytes or terabytes of data, it never works. And it always takes time, no matter how do you build these systems. So we've built our system in a way that allows you to disaggregate these and really give you control of the system. And I think what you're hearing consistently is that this is the power of you having the control of the system in your hands. It's not something that we've enabled on our side to make it better for us. It's really so that you can run your business in a cost-effective and efficient manner so that it works very well for you. So I'm going to break this down a little bit further. So how many of you know the difference between an MPP and an SMP architecture? Anybody know what MPP actually means? Okay, so let's see about a half. So one of the core principles here is that this service itself is built on an MPP processing architecture. It really means multi-parallel processing architecture, and I think it's an important distinction that everybody understands. When we take a traditional SMP system, so SQL Server, the box product itself, it's really based on a shared kind of commodity model. So it has kind of a common component, in this case, typically the bus, that connects all of the components. You have a single OS, you have sets of memory and CPU that are shared across the entire system. And the traditional model for scaling these out is buy bigger, right? Every hardware vendor I've ever seen has said, hey, we've got something bigger, right? Here's our X new SAN, here's our X new HBA cards, here's better processors and better memory. And that's really a hardware play, and it's to solve this fundamental problem. You end up with a bottleneck, and it's very obvious where that bottleneck is. Right? You have this shared architecture, and so you don't get the concept of being able to perform very quickly any kind of operation. I mean, in an MPP architecture, it's truly a shared nothing architecture, and SQL DW is following this exact model. So who's familiar with Hadoop? So I asked lots of questions, so if you don't like raising your hand, you're probably going to get a short soldier by the end of this talk. But really, if you're familiar with Hadoop and you think about the way that kind of traditional MPP models have been built, you can essentially add nodes, add infrastructure into it, and just have the system get bigger. And really, the mental model that I always give people is Think about somebody who's got to sit there and hammer 100 nails. There's two ways of doing it. You give one person a hammer and you say, hammer really fast, right? And it'll take them pretty, if they're pretty good, or maybe even say, you know what, here's a nail gun. Go ahead, put 100 nails in. Or I could say, hey, here's 100 people. I'll give each one of you a hammer. Hammer once. Who's going to win? And who's going to win every time, right? Now, what if I made that 1,000 nails? What if I made it 100,000 nails? Who's going to win? Right? And so you can see the concept of how these different kind of architectural approaches really can solve data problems in a way that you're not familiar with seeing, especially with SQL Server, the traditional kind of SMP architecture. So with this shared nothing architecture, it really means that each compute node is working independently. So as you process a query, what you'll see is a distributed query that gets sent out to each one of the nodes that has a slice of the data. It can be executed, and then the data is aggregated into a final result. Again, those 1,000 people hitting a nail all once. So each system doesn't have to work that hard. And what it means is under the covers, we can use things like commodity hardware. We can use commodity kind of infrastructure so that each node doesn't have to be very dedicated, very expensive. And if you go talk to a hardware vendor, and I apologize if you're in the room, you don't have to go out and buy a 10-rack system with giant, massive disk arrays and all of this to actually perform. This can actually be done on very cheap commodity hardware, which means that we can do it very cost effectively, and we can pass that on to you as a customer. You have the great capabilities of a SQL Server-based infrastructure and using commodity hardware and doing this all at massive scale. So I figured I'd take a kind of another detour and actually explain to you where this all came from. There's a lot of history behind how we ended up building SQL Data Warehouse. Some of this is kind of the way Microsoft has approached the problem, and some of it is just how we arrived at the journey. So the first thing to know is this is actually built on the same infrastructure that runs Azure SQL Database today. So the database itself and the infrastructure concepts are all actually shared between the two systems. So you can think of them as just kind of a single system with different kind of views of the world. So you can imagine that you'll see provisioning experiences that will allow you to see, I want to create a database, and we just ask you to decide what kind. Is it an OLTP system, or is it a data warehousing system? And you can do those from the same common interfaces, so T-SQL constructs, for example. But we're built on these same kind of constructs. So we think about our system no differently than we think about Azure SQL Database. And Azure SQL Database gives you all kinds of things that you would expect from a cloud service. Starting at the bottom with kind of a true SQL Server experience, right? It's SQL Server product. It's the product that everybody knows and loves, the fastest growing database, the largest enterprise database in the world. And it's built on that same infrastructure. We use SQL Server. We don't have any custom code. It's SQL Server. And it really gives you the capabilities that you expect. Standard T-SQL code, all the skills and things that you've learned over the last 10, 15 years working with SQL Server, they translate very quickly to this service. As we launch the service, you'll see us come in with all of the compliance requirements that are in place today with Azure SQL Database. So these are things like HIPAA and PCI and FedRAMP and all of the different kind of compliance requirements that you would expect out of a cloud service. And as you see Sean and Rohan talking about in the foundation session, there's been constant improvements being pushed into Azure SQL Database. The Azure SQL Data Warehouse will take advantage of those. Because they're commingled systems, things that happen there very quickly transition to the SQL Data Warehouse as we build that out to MPP scale. When we talk about things at petabytes running in the cloud, but being able to do that with all of the compliance that you expect to meet your customer demands or your organizational demands, it means we can offer those to you on day one of the service being available. And then finally, from a service perspective, we talk about kind of the big thing in the cloud, right? Is it going to be up? Is it going to be reliable? Can I go build a system on-premise that is more reliable than what we're going to offer in the cloud? And the direct answer is maybe, but it's going to be really expensive for you. We are going to offer at our general availability the same 99.99% uptime guarantee that SQLDB today offers. There's no other cloud provider that's offering any kind of SLA that matches anything close to that. And when you think about running a data warehouse at up to a petabyte or a little over a petabyte in scale in the cloud, being able to offer you guaranteed uptime at 99.99%, you think of, wow, how is this service able to do that? How is it able that I can run a system like this and get all of those things? And why would I even consider building an on-premise solution to match this? There's really not an answer to that other than maybe potentially an Azure compliance problem where we don't have a compliance. But other than that, you're really thinking about this is a service that can scale. It's a service that can grow with you. It's cost effective. And it has all the compliance needs that you need. And it's guaranteed to be up. The last thing to talk about is really how Azure SQL Data Warehouse itself got built. There's a bit of history here, and I apologize for the history lesson. Microsoft offers a product called the Analytics Platform System. Who's heard of it? Wow, really? Okay, I'm a little stunned because it's actually not the reaction I usually get. I usually get one person in the back, and they usually work for Microsoft. That's just kind of funny. Really, for those that don't know, the Analytics Platform System is an MPP-based SQL Server relational data warehouse sold as an appliance by Microsoft. So these are very large-scale systems. We sell them in conjunction with our hardware partners, HP, Dell, and Quanta. And they're sold as pre-configured rack appliances. Essentially, you buy one of these, a rack shows up, there's a bunch of hardware in it, it's pre-configured, you just plug the thing into your network, and you have a very large-scale data warehouse. These things can get really large. We sell up to 6 racks, somewhere in the neighborhood of 6 to 7 petabytes of storage, 60 or 70 compute nodes. It's a really, really big system that you can get to with these. The SQL data warehouse is built on that same premise of that manipulation engine or that MPP engine that runs in the covers. We call it the PDW engine. So if you hear me reference it, that's what I'm talking about. It's really the distributed layer, the distributed query execution system that runs those large-scale appliances. Now, when we transitioned that service or that infrastructure to the cloud, we took advantage of all the things that are available to us. Running PDW, the distributed query engine, at scale means that we can use the power of elasticity that comes to us from Azure, and we can scale it very wide, offering all the things that we've been doing from an APS on-premise sale perspective that we've been in the business for 5-6 years of, and really offering that at cloud scale and optimizing for the advantages that we get in the cloud. In an APS appliance, we have the same problem that we have with any other vendor. If you talk about trying to make the appliance bigger, we have the same expansion problems. You have all of the nodes that you have to add, you add additional storage, and you have to scale, which means I'm going to move data from the set of nodes I started with to the set of nodes that I'm moving to. And you really get this kind of problem of being able to move data. With the service, it takes back that whole concept and says, I just know that I have a set of nodes and I have a set of data setting in commodity storage, and I'm able to process it very quickly. So I've taken away all of the problems and taken advantage of all the cloud components that have been offered to us from Azure. So this is a question I always get asked. Really, is it SQL Server? So when we start to transition and talk about what the product actually offers, it's SQL Server. Under the covers, it's all of the things that you would expect from a data warehouse, right? It has full capabilities for things like stored procedures and functions and table partitionings, right? You can literally load data and into a staging table and alter partition over to a production table, right? It has all the things that you would expect at SQL Server. It has the same SQL constructs. We use the same language base, right? It's SQL Server. We think about things like column store and the optimizations that were made with SQL Server 2014, introducing columnar indexing for data warehousing workloads and the performance benefits that we get there. Those are all advantages that you can take of, or things that you can take advantage of in the SQL Data Warehouse service. It truly means that you have all of these components that are being built around SQL Server as an engineering organization and take advantage of them into the SQL Data Warehouse as you transition into the service. It also means that you have all of the tools and scripting and all of the kind of access that you've had around SQL Server natively work with the product. So you think of things like BCP, right? Very simple kind of command line tool, which is commonly used. I mean, I use it all the time to just move data from one system to another when we're trying test data, for example. Just taking data out of, say, SQL SMP and shoving it into the system, it's just enable. It's exactly like what you would expect. So you're able to do the things that you're very familiar with and makes the transition from what it is you're working on today into the SQL Data Warehouse very easy. You don't really have to change very much. And this means a lot of different things. So if you can imagine, you have SSIS running. You can literally just take your connection string and say, I pointed to a new location, and your SSIS packages will continue to work with the SQL Data Warehouse service. So it really makes that transition and that migration effort much, much simpler for most customers. How many people know Polybase? Again, wow, you guys are like the best audience I've ever had. You guys are great. So Polybase is this amazing technology. It was built in conjunction with the Gray Systems Lab, led by Dr. David DeWitt. If you have an opportunity while you're here, I know he's speaking a couple times this week. He's a great speaker, very knowledgeable. He's kind of a pillar in the data warehousing industry. And really, this was something that our team built in conjunction with the Gray Systems Lab. And it's really this concept of being able to say, we know that as a Microsoft employee, I would love nothing better than everybody in the room to say, I run Microsoft stuff and nothing but Microsoft stuff. That would be the best. But we know that's not the reality, right? There's a mix of everything. And so we talk about kind of places that it makes sense to have data in something like Azure SQL Data Warehouse, and where it doesn't make sense. I think we've used this canonical kind of insurance scenario where we talk about, hey, I've got data that's kind of this structured or semi-structured data that I continue to see in something like Azure SQL data warehouse. We talk about kind of this insurance scenario where, as a customer of the system, I could say, I've got my structured data, I know who you are, I know where you live, this is your credit card, all those kind of traditional things that we would have in a data warehouse. But as car companies start to think about, or insurance companies think about, how do they customize your experience? How do I customize a tailored experience to you as an individual? You're starting to see this explosion of things like devices that you can plug into your car that records your driving history, where you drive, how far you drive, what times of day you drive, and what weather conditions you drive. And all of that IoT data is being pushed up into things like Azure Blob Store and into Hadoop systems running in the cloud. And now you have this kind of disparate data. How do I connect that data? How do I make it so that I can actually do something actionable about it? How do I find the drivers that I need to add a 20% premium on top of them because they're really bad drivers, they drive in horrible conditions, and they drive at way above kind of the speed limit? Probably your 16-year-old is one of those drivers. Or how do I look and say, here's a customer who's been loyal to us, who's been with us for a long period of time, and I want to make sure that they stay with us as a customer. So I want to go and look for people who are very good drivers, who have a great driving record, but also who have been with us for a period of time. So how do I merge those data sets? And we use this technology called Polybase, which really gives you the capability of merging the two worlds. It's a simple set of T-SQL constructs, and I'm going to walk you through how it actually, you create this kind of concept in a minute. But it really gives you this kind of view of this non-relational data sitting out in Hadoop that you would get, say, from weblogs, or in this case, the example of a car emitting this data to the cloud, and be able to join that in a way that makes sense. Not a lot of people want to spend the time retooling their business analysts or their marketing folks or their sales folks to go learn, how do I write a map-reduce job in Java? How do I install tools for interconnecting with Hadoop? Right? That's not really something that's going to be effective for your organization. So instead of doing that, you offer up the same kind of concepts that you've had for years. Look, you can connect to this from Excel and just pull the data down and mash it up in Excel. I can pull it into SSRS or any one of the third-party vendors that you can imagine, the Tableaus, the MicroStrategies, the SASs, the Revolution Analytics before we purchased them of the world, and be able to mash that data. But it's all coming from a simple construct. I don't have to go get data from here and go get data from here, maybe over here and up here, and shove it in a system and figure out how to munge it. You can do it just through simple T-SQL constructs. This allows you to move data between the systems. So if you do want to pull data into one system or push data into another system, say for archiving, you can do that all through this kind of simple T-SQL construct. So I'm going to show you what this actually looks like. I'm actually going to walk you through. I know T-SQL is like the best BI experience, or best demo experience, right? I had to do the T-SQL demos, and I got to see all the cool, flashy BI demos. And I apologize because it's not that fancy. But it's literally this simple. I'm going to walk you through about 3 screens that will actually show you how this gets set up. And it's the exact process you would go through. The first one is you'll create a database level master key, right? Pretty common, and you can see the 2 examples. You can do it just as a simple or non-password required master key, or you can also enter a password. The second step will be creating credentials. So really this is where, in this case, I'm going to actually connect to Azure Blob Store. So you go in and you just add your credentials information. So in this case, the storage name and the secret key that you would get from your Azure Blob Store. The next thing you'll do is what we call an external data source. So who has ever fought linked services in SQL Server? Yeah, that's my favorite one in the world. Who loves linked services? Really? I got one hand. All right, come see me afterwards. I have a prize for you. So external data source. So this is really the concept of basically creating the connection. So we're telling it in this case, you can see type Hadoop. We use Hadoop kind of synonymously here. We don't actually make you type something else, so it's pretty consistent. And then we're showing you actually where we're connecting. So in this case, Azure Blob Store, and we're just showing you kind of the path that you would actually connect to. It's pretty straightforward. And then you supply it the credentials. Actually, how do I connect to it? What's the private key that I would connect to it? So that when we connect out to it, we have all the information to go read the data. Once you do that, in this case, we're going to create a file format. And again, I'm sampling weblogs here, so this could be any format. So you can think of CSVs or anything like that, where you go out and you just model your data, and you say, I'm going to get a bunch of weblogs, for example, and I'm just going to go read those. In this case, I gave it some options. There's a bunch of different options here. I just kind of abbreviated them here for the view. But it really gives you the ability to define how that data is and how you want to surface it. And lastly, you now create a table. And SQL Data Warehouse introduces this concept of an external table. And really when I'm looking at an external table, from a user's perspective, if I then went and created this table, I could just simply go to the SQL data warehouse, select star from, in this case, web logs, and I would just get results. It's that simple. There's no other constructs around this. So from a user's perspective, it's a table. You can permission over the top of it. You can create statistics to optimize it. You can join it to other tables just like you would expect. So I could create a query that says select star from my users that I happen to know, say, or my products table that's sitting in my relational data, and I want to go match it to a URL because I know that that's where people are looking. And I could do the join across the two systems. And that's all done under the covers. What Polybase will do at that point is it will make a determination. It will say, based on the query that you're running, the predicates that you've given it, and some details about the system, how many nodes I'm running in the SQL data warehouse, how many nodes I'm running in Hadoop, it'll make a determination as to where is best appropriately to run that external query. So if it happens to be that you have a bunch of data, say I'm a customer and I've got a very small SQL data warehouse instance and I have a massive Hadoop cluster, say 60 nodes with a petabyte of data. It doesn't make sense to try to pull all that data in and try to do something on the SQL DW side. It really makes sense to run a MapReduce or a Yarn job out to that Hadoop infrastructure. So the data warehouse through Polybase will actually generate a MapReduce job, push that out, or a Yarn job, push that out to Hadoop, execute the job in Hadoop, and stream the results back into SQL DW and surface that as essentially a metadata table that you can interact with, whether that's querying, whether that's moving data, whatever it is you want to do with the data. And it does this all automatically. There's no provisioning by a user. You literally would go to this table and say, select star from table where. It's really that simple. And so it gives you this power of integrating data in a way that you've never been able to before. It's an amazing technology and really unlocks kind of these systems of data, these pools of data that are sitting all throughout your organization, enabling you access to insights that you never had before. And this is used quite heavily in the APS business where it was first introduced. We have lots of customers that use Polybase to see things that they've never seen before. How many customers, the canonical insurance scenario, how many customers do I have that are good drivers that I want to go offer a special to retain their business? Because I know they're loyal, and I want to make sure they stay loyal to us. We're continuing to make a lot of money, and they don't cost me a lot of money. Or how many customers do I have that are doing the opposite? What are the ones that I want to go and figure out, hey, these guys are probably not the people we want to keep. So we either want to do something where we raise their rates because they're costing us more than we're actually making on them. Or you can think of things like fraud detection. You're just shoving all this web log information or data into a giant data lake, and you want to match that with some structured data you have about some information in your systems. This is actually done where we're doing trickle loads into the system where we shove about 50,000 rows into Hadoop, and there's near real-time analytics being done on intrusion detection at a bank in Europe. And they go through and they run these external queries, and they do it every 5 minutes, and they're looking for anomalies over large sets of data to see, is there patterns in our traffic that are showing things like, hey, here's a credit card that's being used inappropriately, and it doesn't follow the patterns of that user in the past. And we're looking at massive amounts of data, not what happened today or yesterday or last week, but what's happened for that user or sets of users at massive scale. Hundreds of thousands of users with billions of transactions, and it's being done every 5 minutes where somebody's looking for an anomaly. And if they flag something, they immediately get those, hey, Mr. and Mrs. Customer, you get a phone call that says, hi, I'm from Visa. We've noticed an anomaly on your credit card. Is this actually you performing this transaction? And they can very quickly find things that are going on in their system by using technologies like Polybase and the combination of the structured and unstructured data. And here's an example of a query. I forgot that this was in here. So really it shows you just that combination. And again, something as simple as web logs joining to a products table. So when we then start to kind of pivot, now that we've kind of built this foundation of this is what the data warehouse is, this is kind of how you interact with it, the final question really becomes, what can you do with it? And again, when I asked that question at the beginning of who uses SQL database, who uses SQL Server, and who doesn't, this becomes a kind of an important component of what actually is happening in the system. So Azure SQL Data Warehouse is a component of the Azure kind of large ecosystem. So as you would expect, we have native first-party integrations with things like Power BI, Azure ML, Azure Data Factory, Stream Insights. Those are all going to launch with Azure SQL Data Warehouse. And it means that we truly have the capabilities of taking each one of those systems and optimizing them at massive scale. So when I talk about Azure ML integration, for example, if you're building out a model, a lot of times you don't actually want to suck out billions of rows from a data warehouse and run it into a model. It's not performant. It's also not efficient, and it breaks all of the rules about statistical analysis. Right? You don't need to have every single row. So let me go get a statistical sample that I can pull in. And the systems understand that Azure ML is going to pull a statistical sample, and it can run a distributed query at massive scale against the data warehouse and use the power of multiple compute nodes at massive scale in order to get the data very quickly, and then allow you to run and process it. But this also means that as we launch the product, we'll also launch with a bunch of non-Microsoft third-party partners. So if we think about what a traditional data warehouse is today, I have a bet. So there is sitting in the front is one of our marketing folks, and I have a bet that there's going to be one person in the room who will say, I run everything Microsoft. So who runs SQL database with SSIS, Excel, and SSRS, and nothing else? Oh, man, I lost that one. Shoot. Okay, so traditionally I only get, like in a room this size, I get one person who says, I actually only run that. I don't run anything else. Who runs Tableau, MicroStrategy, Qlik, Informatica, Tunity, I mean, like, right, everything else. We realize that you're not going to run just our stuff. So we partner with a broad set of SQL Server partners to bring all of them into the fold with SQL Data Warehouse. It means that you'll be able to light up each one of those services or connect using their services directly to the Azure SQL Data Warehouse, enabling you to quickly transition your existing system into this without having to go through the massive migration of, oh, well, the system doesn't support stored procedures, so I got to rewrite that. It doesn't support collation, so I got to rewrite that. It doesn't support partitions, so I got to rewrite that. Oh, it doesn't support this tool, so I got to go get a different tool. Like, it becomes, the cost of the service is small in comparison to the migration cost and effort that your business is going to go under. We've enabled very kind of simple transitions for customers to go from an existing on-premise SQL data warehouse, Oracle on-premise, those kinds of things, Teradata on-premise, and move into the cloud very quickly, as easily as possible without disrupting your business. So not all of your users have to get a new version of Excel or a new version of Tableau that works with the new thing that you're going to run. They can use what they have and just point it at this. Again, I keep coming back to this point that it's traditionally hard for customers to do that, but we try to enable that as simply and as easily as possible. Change a connection string and it just works. You have BCP, for example, and it just works. And so all of the things that you do today just work. So I promised that we would get to this. So the concept of a data warehouse unit. And I started this whole conversation talking about spindles and cores and sands and all these interesting things that we talk about in kind of the weeds. But really, when we get to the cloud, the concept is that it doesn't really matter. It's my job and my team's job to figure out how we provide you computational power in a way that makes sense. Whether that's a mix of cores and memory and network capacity and local storage and remote storage, that's really what we spend a lot of time on. Microsoft's a great framework company. We've been doing this for a long time, and this is really where we're kind of experts on setting these systems up. But what this means from your perspective is you don't really start to think about things like, oh, how many cores does this have? It doesn't matter. It really doesn't matter, because how many of you have ever sat in front of your boss and said, hey, the reason I can't get you this query, the response to this is because I don't have enough cores. It's not the question. The question is, I want to know how many customers am I going to impact by putting a 20% discount? What's that going to do to my gross margins, and how fast can I turn that data? That's the question your boss is going to walk into your office and ask. And so they want to know those kinds of details. They want to know how much data can I push into the system? How is my trend year over year on seasonality, say, for a retailer? So as we get close to the holidays and they say, as business increases and my competitors do these kinds of discounts, what's the impact on my system? That's really the questions that you want to get at. We've always answered that question, and I'm guilty of this more than anyone. We've always answered that question with, well, in order to do that, you're going to need 6 more cores, or you're going to need this much more memory, or we're going to go to 15,000 RPM disks, or hey, maybe there's these new things called SSDs, let's introduce those. But that's not really what you're getting at. You're really just getting at, I have a pool of data, how long is it going to take me to get through that data? That's really the question you want to get at. And then you just get to make a decision on how much does that cost versus how important is it to me to get through it at a certain kind of concept of speed or latency. So when we introduce this concept of DWU, the idea is that we're going to give you some basic metrics, those kind of 3 common metrics that traditionally are asked. What's your scan rate, what's your load rate, what's your table shuffle or move rate, and we're going to define those. Right now they're in final definition, so again, you're getting kind of early views, but this is really what we're going to define. We're going to say, for a particular set of data warehouse units, and these will be sold in blocks of hundreds, so I have some samples here. For a particular set of DWU units, this is how long it'll take you to get through a canonical scenario. So I've just modeled one up here. If it takes you, a certain period of time to get through, say, 1 billion rows, and we start at the small size, just 100 EWs, it'll run some period of time. And again, these are just sample numbers, so don't take them as fact. But really, you look at, say, 297 seconds it takes you to get through a query of a simple scan. As I increase the power of the system, you can see it just scales. And so the faster I want that query to be answered, I can just apply more horsepower on it, essentially. And it really gives you the control of what you want. There are some queries where it's okay if it runs through the weekend. Nobody cares. Right? It's just got to run through the weekend as long as it's done by Monday at 8 a.m. That's fine. There are other cases where your boss walks in the office and said, hey, I need this answer now. Can you get it to me? You could go to the system, scale it up immediately, run your query, get an answer in just a minute or two, and then scale the system back down. It's completely available to you as a service. Or maybe you have seasonality where you say, every Tuesday we run executive level reports. And so Tuesday morning, you scale the system up, run your queries, and then scale it back down. You have all kinds of capabilities based on this concept of a DWU. It's essentially a computing unit. As we kind of start to wind up this session, we start to talk about things like price performance. So really when we start to talk about these kind of capabilities, you can really see that these systems, the SQL data warehouse system really gives you the ability to grow from very small sizes to very large sizes. Now, it's hard to draw what this actually means. If I draw a chart that looks like this, it says, hey, you can kind of be anywhere in between. The dimension that we're missing here is time. So this looks like over time, I'm growing and I'm growing and I'm growing. But really what you're missing is the ability to go up and down whenever you need it. I know I keep talking about this kind of elastic model. But truly what people do with data warehouses is they think about, how do I run this business? And with the introduction of elasticity, their mind starts to change. And really when you get in front of a customer and you say, Mr. and Mrs. Customer, you can run your data warehouse this way now, and an hour from now it can be completely different. And I'll give you a great example. We have a customer who runs a very large data warehouse today. It's just north of 800 terabytes. It's a large national retailer. And they have this very, very large system. Right? And they store a lot of data in there, and they do all the things that they do to make sure that the systems perform, and they partition data appropriately and stuff. But once a month, they have to do month over month and year over year and quarter over quarter calculations. And so they built their system to model exactly that. And it's done on a Friday, and it typically runs for about 36 hours on a very large analytics platform system. It's a very large system. But most of the time, they're not doing that. So you would think, well, they're really purchasing for high performance, this kind of top part of the chart running up here, and they're paying for it. But most of the time, they actually want to be here. They really only have that archival scenario where they're storing their data, but they only need compute really once a month. And so trying to draw a picture that depicts that is really hard. But what it means is that the customer has the ability to say, hey, it's Tuesday. Make the system bigger because the boss needs an answer today. And then as soon as they're done, make it smaller. And it really gives you kind of these models of building the system that matches your needs. So if you have balance needs, if you have growth needs, you can do this in any way. And again, as you add data, the system can just scale from a data perspective. As you add compute, you can scale there independently. So you have this model of really building out systems that match the needs that you have. Kind of the last concept here is really this concept of data growth. So when we talk about this kind of bottom axis here, you can see that you can start very small sizes. We just picked 100 gigs here for the chart, but you can start at a very small size, and the system will just grow with you. So there's no concept of having to move your data at any point in time in the system, whether you're 100 gigabytes and growing that to a petabyte plus. You could stay in the same exact system that you started with, and it can just grow with you over time. So I don't have to back up my system, build a new cluster, make it bigger, restore, expand my data into a new size. It's just something that's done automatically for you when you just slide the slider or give it a T-SQL command to make it bigger. And it really gives you the capability of a business of saying, well, I'm going to go try this. Right? It's a cloud service. I could go try this afternoon, provision a service, do a POC, run a pilot. Maybe it takes me a week to get everything I need set for the customer, whether that's my boss or whether it's a business unit that I'm working with. Provision the service, pilot all that, go run my pilot, and at the end, turn it off. Right? If you had to do that with a traditional data warehouse, that would take months. Go get a hardware. Go provision the hardware. Get it put in your data center. Move your data. All of those things would take you months to get set up to do, and something you could do in a couple hours running a cloud service. And it really gives you the capability to say, well, now that we have that pilot, I set everything up, let me grow the system. Let me just make this my production system and just grow. Start adding your real data into it and start to grow the system. And it can grow to massive scale. So kind of winding this down. So Azure SQL Data Warehouse. When we think about kind of the things that really are kind of the core tenets of how the service works. It's this core concept of separation of storage and compute. I know I talked a lot about that here. It's really this core kind of architectural decision to say, we are going to offer the service to you in whatever way that you need it. This concept of elastic scale and really allowing you to build out the system with whatever size that means to you, without backup and restore, without data movement, and really being able to move the system in a way that's performant for you. And finally, kind of this symmetrical integration with all of the different services that are available, both first-party Azure services, first-party Microsoft components, Excel and SSRS and those kinds of things, SSAS, SSIS, all of those components, as well as a large ecosystem of third-party partners, and really offering up kind of these capabilities for you to have a data warehouse that works for you at your scale, at your needs. With that being said, I actually purposely left this a little bit short. I assumed that there were going to be some questions, and so I'll try to answer as many of them as possible. If you want more details, we launched a page this morning. You can go to aka MS SQL DW, and it'll give you a lot more details. You're also able to sign up for the public preview there to have early access to the system as it launches later this summer. With that being said, thank you for your time. If you have a question, I just ask that you come to the microphone, as this is being recorded, so it can be heard back by anybody that's listening. With that being said, I appreciate your time this morning, and we'll take the next 10 minutes or so to answer any questions you have about the service I didn't answer. Thank you, everyone. Down the back.
Hey, Matt. Data load.
Data load.
Talking about 10, 20 terabytes. What are our options for getting the data to Azure?
How do you get that data actually in? That's a great question. You have a couple different options. Azure's SQL Data Warehouse works with, obviously, the first-party tools we were talking about, SSIS and Attunity, Informatica, those kinds of things. But if you have a large data set, you have a couple options. If the data is already cloud-born and it's sitting in Azure Blob Store, you can just use Polybase to pull it over. Azure offers a couple of different services. One's called the Express Route, which is a dedicated telco circuit from your data center to the cloud, which gives you a dedicated circuit, fast pipes, in order to pipe the data into the service. And the last option really would be the Azure Import-Export service, or the Pigeon service. So you can essentially back your data onto a disk, ship it to Microsoft, and we'll put it into Azure Blob Storage for you, and then you'll be able to suck it right into the service. It's a great question. Are there any other questions? In the back, yeah.
Since queries are going to be costing real money, with bad queries, is there any visibility into the execution plan?
So it's a reserved space. So I want to make sure maybe I wasn't clear. So when you provision a set of DWU, you're guaranteed a slot of compute power. So it's not provisioned on a resource usage-based model. So you're not going to be charged on, I ran a query and I got halfway through and I realized I had a loop that's just on a loop and it's running for 4 hours, for example. So you're just provisioned on, hey, I want this number of DWUs and you're being charged for the reserve capacity. Does that make sense?
Yeah, like with normal SQL, when you look at the execution plan, is there going to be something, a tool for that?
Yeah. Okay. Sorry, I misunderstood your question. Yes, so it's SQL Server, so you can run explain plans and you can see query plans, and we have a bunch of DMVs that'll tell you what's in the distributed nature of what's actually happening in the system. You can go look at kind of the distributed query plans and the individual steps. Those will all be available to you through DMVs, at least initially.
All right, thanks.
So what about the APS limitations, and how do they map on to SQL DW, or were you able to leave them behind? Row size limitations, or row size, and some of the other limitations that APS has?
Sure. So great question. So APS does have some limitations in things like row size. That's a great call. PDW is built on kind of this model of distributed querying. As we moved that into the cloud, the first targeted goal was build this core set of reliability of the system running in the cloud. And so we've removed some of the limitations. We've introduced some new things like extended table types. So we introduced a new concept of like a round-robin distribution table type. There's a current model working around concurrency slots and the amount of kind of workload management associated with each query and memory grants and those kinds of things. There's been a bunch of improvements in that area. There's some things I don't want to talk about here publicly yet, so we're not ready to talk about. But there have been some improvements in kind of some of those limitations. Some of those limitations exist, and specifically row size I'll talk to. It's something we can talk to specifically. We do have the same current limitation that we have in the APS appliance. It's no different in the cloud. We do have a design that we're working on that will extend kind of row size and some of the things that you can do in an individual row size when we move data throughout the system. And it's something that we're working on. I don't have timing that I'm not going to announce publicly, but it is something that we're working on.
So the same architectural concepts like distribution key, replicated table versus distributed, those things are still there and present?
Yeah, so you can go in and create, I didn't show it here, but you can go in and create like a hash-based distributed table. It's the same exact syntax that you would run in an appliance that you see in the cloud service. So create table, distribution equals hash, pick a column. CTAS, all those functionalities that you see in the appliance today are available in the cloud service.
How much of that maps down into SQL, just normal SQL Azure versus SQL Azure DW? Because you talked about kind of as a continuum, you start with that as a base and then scale up to SQL Azure DW.
So that's another good question. So they are distinct operations. Like if you were running SQL DB today, you couldn't right size from SQL DB into SQL Data Warehouse. You will move data between the two services. We think of them differently, right? SQL DB itself is transactional system. So you think of things of like concurrency. Right? SQL DB is all about concurrency. How many transactions can I run concurrently? Data warehouses are focused on latency, right? How long does this one query run? Because I'm not going to have people running the front end of some service online right behind this thing. But when we talk about kind of the core functionality, really, you think about running SQL Server under the covers, and that's what our nodes are running on. Both our nodes and SQL DB share that same kind of common infrastructure, SQL Server at the bottom. It's really the distributed kind of nature over the top, the PDW engine that runs all the distributed querying that's different. I know I didn't answer your question directly, whether like something transitions very simple from SQL DB right into SQL DW. They are distinct, and so I do want to make sure that you understand that. But there is a merging of these products at some point in the future.
So, for example, Polybase will be coming to SQL DW, not to SQL Azure.
In the initial release, that's correct.
Okay.
If you saw the SQL Server 2016 launch yesterday in the announcement, you will know that Polybase as a core functionality is landing in SQL Server vNext or SQL Server 2016. So you can see Polybase will be enabled in all of these scenarios. Now, if you paid attention to what Sean and Rohan were talking about, all of these kinds of capabilities are generally lit up in the cloud, very quickly. And so we're able to do things at the cloud, use this kind of cloud-optimized engineering model, and deliver good products into the box. Polybase is actually one of the few technologies that was done the opposite. We built it in the box first, and we're going to go enable it in the cloud second. So I don't have timelines as to when Polybase would be enabled or if Polybase is being enabled in SQL DB, but it is definitely something that's obviously a valuable service, and you can imagine that we'll light it up at some point. So, right?
Can I ask a few more?
Sure.
So DW Loader, was the preferred way to go into APS because of it kind of inherently knew the distributed nature.
Yeah.
I didn't see anything like that talked about, and you mentioned SSIS, Data Factory was up there. Are those smarts built in, or does that recommendation come forward? And if so, what would that look like?
DW Loader specifically won't be supported with the cloud service. It takes advantage of some things we can do in the appliance that we don't have access to in the cloud. Some of that kind of concept is really being built into some of the technologies under the cover. So BCP on the server side and then TDS protocol on the server side are things that we're enabling so that you have access to that kind of parallel loading kind of infrastructure. From a cloud perspective, if you have data that's landed in Blobstore or Hadoop running in the cloud, we recommend Polybase as kind of the alternative method because it runs in parallel across either Blobstore or, say, Hadoop. And so you get that parallel nature of load. So that's kind of a common recommendation.
So if you're doing just kind of your traditional ETL loads in using something like SSIS or ADF, connecting to like an on-prem SQL database or something, there were with APS connection, the number of connections queued up, the number of loading connections and stuff like that. Are those limitations looking like they're still going to be around, or?
Yeah, I'm not going to speak publicly to that yet.
Okay.
There are some things that we're working on there that are a little different. So that's all I'll leave you with here. But,
Gotcha. Thanks.
all right. Well, that said, it doesn't look like there's any more questions. Thanks, everyone, for your time, and enjoy the rest of the week here at Ignite.